Yesterday we talked about a little bit of graphing. The first thing that we said was every function is able to be graphed. Are some of them going to look real funny? Absolutely. Absolutely. But they're able to be graphed. Okay? We will be doing the graphing. Okay? How many points did I tell you yesterday that we had to use? How many? At least 3. Yesterday I said we had to use at least 3 points. I'm going to put in parentheses 5 points. You'll see why in a second. And then we talked about one specific type of function yesterday. What type of function did we talk about yesterday? Cody. Yeah. We talked about linear functions. We will be spending probably at least 2 months, maybe 3 months dealing with linear functions after this unit, like another 2 months. And it's going to be painstakingly long, but my gosh, I'm going to get you ready for algebra. Linear functions, when graphed, are a what? What do they have to be when they are graphed? They have a straight line. Good. Are a straight line. You will absolutely have to graph linear functions. And yesterday I gave you a bunch of examples. I said, okay, f of x equals x. That's a linear function. F of x equals 3x, linear function. F of x equals x minus 3, linear function. F of x equals 4x plus 7. All of these are linear functions. And as simple as I can make it for us, what makes them linear functions? What are we trying to look for? It's going to make it a linear function, Sam.
Well, when you connect the points with one line, it has to be a straight line.
Okay, so when we graph them, they'll be straight lines. What if we just look at the functions? Oh, no, it's me. It's me. I've been having fun all day. Hi, this is Mr. Holmes' facility math class. Okay. Okay, would you like that now, or would you like me to wait until she comes in? Okay, thank you. Bye-bye. Madison. Hi.
Hi.
What are you doing? We're just saying hi, Madison.
Okay.
You need to go to the office, though. So, what do we know just by looking at these linear functions? What makes them linear? Emma?
The x has an exponent of at least 1. And it can't be greater.
It has an exponent of what?
1.
Of 1. These linear functions have an exponent of 1. Thank you for shutting the door, Madison. Now, is that the only way? No, because right now if somebody who's in higher math says, that's not true, it's not true. But right now, if you see an x and it has an exponent of 1, we're going to assume it's a linear function. Okay? I'm going to kind of dumb down the math a little bit. Linear functions, which means they're straight lines. Everybody with me? We are going to learn one other type of function, at least to graph. And it is a quadratic function. When graphed, it forms a U, or what I call an umbrella. Okay? Quadratic functions will either be a U when graphed or an umbrella. They will not be a V. That's important. Quadratic functions will not make a V. It's a U. A U is a different shape than a V. If you don't know the difference between a U and a V, ask your ELA teacher to show you. Okay? Mix an ELA in with this. Yeah. They've got those fancy Chromebooks. I bet they can show them on the computer.
Probably, yes, that'd be great.
Now, what are some quadratic functions? Quadratic functions, plain and simple, is anything with x squared. If that's my largest exponent, it is a quadratic. So f of x equals x squared. F of x equals 2x squared. F of x equals x squared minus 1. F of x equals 3x squared plus 4. Those are all quadratic functions. Immediately looking at a graph, you need to say, okay, or not at a graph, I'm sorry, at the function, you need to say, okay, if I'm graphing any of these four functions, my graph needs to be what? A straight line. Great job. But if I'm looking at these, my graph better be one of two shapes. What's one of the two shapes? Michaela? U or an umbrella. Those are the three shapes that we will be graphing. Are there other shapes? Yeah, you could graph circles. You could graph S's. You could graph these like tangent curves. These are the only two that we're going to be graphing right now. I'm going to put a little side note with quadratics. Yesterday, how many points did we need for linear? How many, Brock? How many?
3.
At least 3 points. I know, wild guess. How many do you think we're going to need for this quadratic? Go ahead, Brock.
5.
At least 5. Okay, so we're going to have at least 3 or at least 5 points. We are graphing these two things. So, let's take a wild guess. Not even a guess, but all we're doing for the rest of the class is we're graphing. Woo-hoo, yes. All it's going to say is graph. I'm not giving you anything to do besides graph. If I give you f of x equals negative 2x plus 4 and ask you to graph, what would be your first step? What do we need to do first? Cody.
Enter numbers. So just
What do you mean numbers?
X value.
For what though?
To the graph.
Okay, but you...
Plug in the
Yep. Yes. What are we calling that? Help them out. What do we call it? Because my guess is Cody means this thing.
linear. No.
Ellie? The T-chart. A function table. An input-output. So you're going to make an input-output table. Okay? What 3 numbers do I want you to use? Do you have to use them? No, but what 3 numbers do I want you to use? And I should see almost everybody's hands up. Cheyenne?
0, 1, and negative.
1, 0, negative 1. Those are my go-tos. Okay? Those are my go-tos. Everybody with me? Graph, go. So I'm not going to give you a function table. You are going to have to make your own function table and then choose numbers. Again, do I care if you use these three numbers? No, but for me, I like to keep my numbers small. Maybe Oscar's like, you know what, Mr. H, I hate your number of 1. I want to use 100. Hey, more power to Oscar. Oscar's going to have to count a lot out to 100 to graph it, though. Okay, I try to keep my numbers small so that it's easier to graph. What do you see on this? Yeah, close. If it doesn't form a line, you probably screwed up. Good news and bad news for you. What? I got you. Good news, bad news for me as well. What about the top? Okay, so what am I going to put in for my y value? I need hands. Cody's like, listen, this is too easy for me. I need somebody other than Cody. Curtis.
So what do you want to do first, you're saying?
No, I want what my y value is for when x is 1.
2.
Good. Negative 2 times 1 is negative 2. Plus 4 is 2. Lydia, my y value when I have 0 is x. What? 4. Okay, last but not least, when I substitute in negative 1. 6. Now we can graph. Over 1 up 2. 0 up 4. Negative 1 up 6. You have to make a straight line. Why do we have the arrowheads? It does keep going. Do you know why? Why? Why does it keep going? Emma, stop this.
Because it represents all the possible solutions.
It represents all the possible solutions. There is no number that we can graph that wouldn't work for this function. Okay? Questions? Pretty easy. Okay, moving on. Let's graph this guy. It's going to get a little bit trickier, or at least a little bit different. Let's go. F of x equals x squared plus 1. So you need to look at this now and say, what type of graph am I graphing? Is it linear? Is it quadratic? Because that's going to tell me how many numbers I need to graph. So is it linear? Is it quadratic? Now, I haven't shown you these before. How many points do we have to use? 5. I love that you knew it was 5. How do we know it's 5, Justin? What type of graph is it? What type of function is it? Quadratic, good. So we're going to have our XY table. Could you use any points? Sure. Do you think we're still going to use 1, 0, negative 1? Yeah. What 2 more points do you think we want to use? Cody?
2, negative 2.
Very good. So we're going to say negative 2, negative 1, 0, 1, 2. Those are my go-tos. Okay, substitute in, graph. Let's go.
For scraps and stuff, I can start using this type of paper.
Fine with me, but we need to start bringing our own paper.
I have my own notebook paper
Okay.
in my binder, but when we do crafts, I think this will help.
Yes. No, I think it would too. Go ahead.
I don't know where to get this paper.
We have some in this one.
Oh.
Yes.
You said you need to
No,
bring.
no, no, no. That's not right. But go ahead. So, if x is negative 2, what are we going to do with that?
I'm gonna add it to.
We're not going to add it to anything. If x is negative 2, what is this expression telling us to do?
Multiply.
Okay, we're going to square it. So
Or
if we square negative 2, what are we doing?
Multiplying twice for adding.
Multiplying. So
Yeah.
negative 2 times negative 2 gives us what?
Positive 4.
Okay, so
Okay, so
positive 4 plus
please,
1
please,
is,
please pay attention to this part.
Okay, so write that down. Sorry, I didn't
Remember,
Sure.
just the x is getting replaced with the parenthesis. So I'm going to have f of x equals a parenthesis squared plus 1.
Times negative.
So this is really negative 2
No, this is
squared
squaring.
plus 1.
We're not multiplying.
What is negative 2
Negative
squared?
1 times negative 1 is what?
No. What's negative 2 squared? Emma?
4.
4, because it's negative 2 times negative 2. Negative times a negative is positive. 4 plus 1 is 5. Negative 1 squared plus 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. 0 squared is 0 plus 1 is 1. 1 squared plus 1, well 1 plus 1 is 2. 2 squared plus 1 is 5. Now, watch what I'm going to do here. Negative 2 and 2. They are opposites. Would everybody agree with that? If I graph, okay, or when I graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 2 is 1, 2 to the left, up 5. Does everybody agree with that? Its opposite is positive 2. It's that many spaces away. Notice that their y values are the same. In quadratics, the opposite x's have the same exact y's. So negative 1 goes up 2, positive 1 goes up 2. And then we've got 0, 1. What shape does this have to make? Go ahead, Matt. Come on, you got it. Let's go, Brock. What is it? No, what's our two shapes that it's going to be if it's quadratic?
A U or an umbrella.
A U or an umbrella, which one's this going to be?
A U.
A U. So when I come in, it has to be a U. It will not be a V. A V is a different type of function. If you draw me a V, I will mark it wrong. A V is for absolute value. Right now, you don't know absolute value functions. So don't draw me a V. Everybody with me? Let's do one more, and then I'll give you your homework. Last one. So f of x equals negative x squared plus 3. Make sure you know where the parenthesis goes. So if I were to draw this or write this with the parenthesis, how would I write this with my parenthesis? How would I write this so that I know where I'm substituting it in at?
I think it did.
Come on. Go ahead, Maverick.
Don't worry about the next one. I want to make sure.
So f of x equals, I want you to tell me exactly what I'm doing.
Negative 1,
Negative 1, good.
parentheses, in a,
For some we can Jesus, the text will wind up.
Okay. Plus 3. This is what we're using to substitute in. Very good. Why is it negative 1 times this parenthesis?
-2, -3, -4, -5, -6.
Yeah, because a negative smack dab up against parentheses means multiplication. Good. So find your 5 numbers, substitute in. Let's see what kind of graph you're getting. So you are substituting numbers into that parenthesis and solving. That's it.
These two coordinates and put them on the graph. So what are you going to do here for the -2, 5? Okay. So do the next one. Okay. Do the next one. Okay, do the next one. That's not what it is. These two answers are not correct. Okay, go ahead. So this is 1, 2, 1, 2.
So every time that we have quadratics, we should be using the same 5 numbers.
Okay, so now what do you do with those points? You connect. Okay. Okay, that's what you do. It's not going to be perfect. It kind of does look like it, but it's all right.
I don't know what he's saying. I don't want to get something wrong just because of a little letter shape.
No, a V plus looks like this.
I mean,
Okay, it can't look like this. It's gonna look more like that. And if it's not perfect to you, it's okay. Alright? It's just not gonna be linear. Or it's not gonna be kind of a scatter plot. It's not gonna look like that. Okay?
it would, and then it could also look like that. And then gray.
Okay.
So now we want me to
Go on to the next one. X squared plus 3, right? Okay, so you're gonna
Which one is the problem?
Over here on the left. Upper left equals negative one squares plus three. This one? Yeah. So negative 2 times negative 2 is what? Now it's negative 2. So negative 4 plus 3.
That was a negative 1. 4 times a negative 1. Plus 3.
Did I get it
Okay,
written down?
I'm seeing a lot of mistakes. I'm seeing a lot of mistakes that I want to clear up before we keep on going too far. So, let's start with the substitution. We have to make our T-chart. Again, do you have to use these 5 points? Absolutely not. Do I think these are the 5 easiest points? Absolutely. -2, -1, 0, 1, 2. So with -2, I'm going to substitute it in. -1, this is for my x. -2 squared plus 3. -2 squared is what? That means -2 times -2, which is positive 4. So now I've got -1 times 4 plus 3. -1 times 4 is -4 plus 3. -4 plus 3 is -1. Everybody with me there? What also should be -1? For which x? For positive 2. Can I check this? Well, sure. It's going to be -1 times 2 squared plus 3. -1 times 4 plus 3. That's -4 plus 3. Oh, that works. Remember, opposites give me the same y value. So let's find -1. So now I've got -1 squared plus 3. -1 squared is 1. 1 times -1 is -1. -1 plus 3 is 2. Curtis.
Isn't a negative times another negative a positive?
It is, but we don't have a negative times another negative. We have -2 squared, which means -2 times -2, which gives me a positive 4. 4 times a negative is negatives, because it's positive times a negative. 0 squared is 0. Times a -1 is still 0. Gives me 3. What does this 1 have to be? 2. Because if this -1 has to be the same, so now we can graph 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I'm going to hover over my origin. I go down 2 to the left, down 1. There's -2, -1. -1 up 1, 2, 0 up 3, 1 up 2, and 2 down -1. Well, it's certainly not going to be a U. What's it going to be? An umbrella. Okay? It's upside down. You have to be careful of how you substitute in. Your homework are these 4 problems over here. It says graph them. Nice and simple.